transported in wagons and dumped through a riddle into a crushing machine in order to break it up into smaller pieces. From here, it was raised by a continuous bucket elevator and deposited in silos according to its origin and calorific quality. When it was required by the boilers, the correct mix of coal was selected from the silos and raised by another continuous bucket elevator to the top of the building. From there, it was released into the furnaces below through a system of tubes that you can follow on the diagram. Now, let's see what used to happen in the boiler building. Inside the furnace, the coal was burned on a traveling metal grate, which rotated very slowly while the coal gradually released heat. Some of the coal would fall to the grate, but it was collected and reused. At the end of the traveling grate, the coal, by now transformed into ashes, was collected in wagons and taken to the refuse pit outside the station. But let's go back to the boiler. Its purpose was to transform water into high-pressure steam for the turbines. The heated water passed through numerous tubes inside the furnace, where it was heated to a very high temperature by the boiling coal. Here, it turned into saturated steam, and after passing through a winding circuit of more tubes, gave off humidity. The steam then returned to the furnace, where it was superheated to the level required by the turbines in the machine room. You can follow all this in the diagram below. The hot air near the ceiling of the boiler room was sucked into special pipes, which carried it down underneath the furnace and helped keep the coals burning. The smoke from the furnace was expelled from the building through tall chimneys on the roof, as you can see, after the soot had been removed in order to reduce air pollution. But let's go down to the machine room and see what happened to the steam. This is where the turbo generator units were housed, made up of a turbine and an alternator linked by a shaft, which is where electricity is generated. On entering the turbine, the highly pressurized steam set the blades in motion, causing them to rotate at very high speeds and turn the alternator. After finishing this job in the turbines, the steam is channeled into the lower level through condensers, where it becomes water once again. The condensation process is caused by the steam cooling down on coming into contact with cold water sucked up from the river, as you can see down there, which would then circulate through numerous tubes inside the condenser. The water resulting from the condensation of the steam was pumped up into a holding tank and from there back into the boilers, thereby repeating the cycle. But let's go now into the machine room, where we have already seen the high velocity rotation of the turbine turn the alternator, which in turn produced electricity. The electrical current passed through 3 exit-output buses into a substation, here symbolically represented by a transformer. The voltage is increased to enable it to travel long distances until it is able to reach consumers. This, in short, is how the Centrale power station worked until the middle of last century. Now, after that brief introduction, we'd like to invite you to take a tour of the museum, where along the way you'll find much more detailed information about the wide range of equipment which makes up this power station. We suggest you begin in the high-pressure boiler room, where the steam is generated. Later on, you'll be given further indications about the route we suggest you follow during your visit to the Electricity Museum of the old Centrale power station. We hope you enjoyed it, and that we'll see you again. Thank you for watching, and goodbye.